Hi, everyone. I am doing this recording on July 16th, 2021. And as of today, the percent problems start on page M14. So if that page number has changed from when you had the class, or for my future students watching this, that page number might change, but I think the information is still going to be useful to you to know that we're going to talk about percent problems. And this information has changed quite a bit over the years that I've been teaching this. So you may want to stay tuned. I assume that's why you clicked on watching this video. First of all, problems involving percents are very common on the TEAS. The word percent means divided by 100. When you see the word percent or the symbol percent, remember it means that number over 100. So for example, 25%, that's the same as 25 divided by 100. That can be reduced to 1 over 4 by dividing the top number and the bottom number by the same number, in this case 25, and getting 1 over 4. If I go a step further and turn that into a decimal, it becomes 1 divided by 4, or 0.25. I have a little schematic here, a little demonstration how you can go from a fraction to a decimal by taking the top number divided by the bottom number. And you can go from a decimal to a percent by multiplying by 100. Now you'll find that your decimal will get 2 places larger, moving the decimal 2 places to the right to make a larger number as you go from a decimal to a percent. And I know it's 2 places because I'm multiplying by 1 with 2 zeros with the number 100. If I want to go in reverse, well, then I want to make my number smaller. I'm going to divide by 100 or move my decimal to the left 2 places because there's 2 zeros in 100. Then if I want to go from a decimal to a fraction, I write the number without the decimal, and then I put it over a multiple of 10. Now, by a multiple of 10, it depends on how many numbers were after the decimal in the original number. It's going to be on the bottom, a 1 with the same number of zeros as the digits that were behind the decimal in the original number. So let's see. There's some examples on page M3. And I can show you with this one here, with the 0, what were we working with? A decimal, 0.25. Notice how it became 25 over 100. That's because there's 2 decimals, 2 digits after the decimal, 25. So I rewrite it without the decimal, and on the bottom, it's a 1 with 2 zeros because there's 2 digits after the decimal in the original number. I want you to memorize, if you haven't already, that 1/4 is the same as 0.25 or 25%. 1/2 is the same as 0.5 or 50%. 3/4 is the same as 0.75 or 75%. You may want to memorize these approximate values, and I forgot to turn them into percentages. So 0.333 is the same as 33.3%. And 0.667 is the same as 66.7%. And one thing I want to point out, if I haven't already, or just to reinforce, that I find that when I'm doing the approximations, when turning the fractions into decimals, that I keep 3 values after the decimal. That's been working really well when I'm looking at answer choices. And my answer will be very close, if not exactly the same as an answer choice, if I've kept 3 decimal places in when I've put it in my calculator and stuff during the calculation. So 1/3, think of it as 0.333, and 2/3 as 0.667. These other guys, well, they have an infinite number of zeros after them, so it just goes to 1 or 2 decimal places. Let's try these first couple ones. Write the number 0.999 as a percent and as a fraction. So I'll give you a few moments to stop your playback, and then you can give these a shot. Okay, welcome back. Let's see what you got. 0.999 as a percent. I'm simply going to take that 0.999 and multiply by 100 and get 99.9%. Almost perfect, right? My fraction. For my fraction, I'm going to rewrite the number as just 999. We do not put a decimal in a fraction. This will end up being 99 divided by a 1 with 3 zeros. There's 3 nines after the decimal place, so I have a 1 with 3 zeros on the bottom. 999 divided by 1,000, and there's no way to simplify that by dividing the top and the bottom by the same number. I don't think there's one that we can do. Well, there you go. Now, example 2, write the fraction 8/9 as a percent. I do not know of any way to go directly from a fraction to a percent. You will need to go through the decimal form on the way there. Yeah, it's required. There's a train station on the way. Give you a moment to pause your recording. Okay, so to do this one, we're going to do 8 divided by 9, which is 0.889. And then we multiply that puppy by 100, and we get the decimal moved 2 places to the right, making the number larger, and it will be 88.9%. Now we're going to go into solving essentially word problems for the T's that involve percents. And I figure there's 4 common types for these. And then as the problems that we'll see on later pages that still involve percents, we're still going to be using especially one of these formulas over and over and over again. So let's take a look at the 4 common types of percent problems and strategies for solving them. Again, I've taught this many different ways over the years. I'm pretty fond of the methods that I've got at this point. So hopefully you'll like at least a couple of them as well. Let's take a look. For the first idea, calculating the percent that an amount has changed. Then we'll look at calculating the percent of the total amount, calculating a part of the total amount, and calculating the total amount. And apparently it has the word there. So by the time you get this handout, I will probably have changed this. I think I changed the order, which is why it still has that word "and" there, just like a cliffhanger. Yeah. Number 1, calculating the percent and amount has changed. This is known as the percent change, or percent increase, or percent decrease. And the bottom line, what we're looking at is the amount something has changed divided by the original amount. And then because it's a percent for the answer, we take that and multiply by 100. Our amount of change, it depends on what you're given. They might say the amount changed by $500. So then you already know, you just plug in 500 for the number on top. They might say it was originally 1,000, now it's 500, and you're going to have to calculate that the amount of change is $500. Or they may say it's been discounted by $500. So then you again know the amount of change is 500. It could say reduced by $500. Then you already have the subtraction done. So if they tell the amount of change, if they say it's reduced by, if they say it's decreased by, or increased by a certain amount, then you don't have to do the subtraction. They've already given you the number on top. If, however, they give you a new value and an old value, you're going to want to subtract. The percent increase or decrease will then be the new value minus the old value. You have to finish doing that calculation, get a number for that, then divide by the old number or the original number. This is the part where people make a lot of errors. They accidentally divide by the new value instead of the old value. One thing that you can do to help with this is to, when you read the problem, make a note of which value is new and which value is old. So if you're given an old and a new, assign them first, then use a formula. And I've shown you here how I write it on my paper. I do n minus o over o, and I have the parentheses on top to remind myself to get that answer first before I divide by the original amount. If you get a negative answer, if you use this formula perfectly and end up with a negative answer, that's just letting you know that the price or whatever the amount is, that it decreased. It's okay to have a negative number. The answer choices probably won't be negative, but they'll be called a percent decrease. The formula works even if you get a negative number. That's usually a good sign. The price went down. Let's take a look at an example. With all of these percent problems, I recommend estimating the answers if possible. Now, there's a few on here where I didn't suggest estimating because it can be a little hard with the information you're given. But in a lot of ways, it can be a quick way to get an approximate answer. It works great if you have answer choices that are really far apart. You can quickly at least eliminate answer choices, if not narrow them down to one without even doing the calculation. And if you do that, if you do an estimate, I want you to pick the answer choice that looks good from your estimate, flag the problem, and move on. Get through all the problems in the math section. Then you can go back to the flagged problems and go through all the steps of calculating the exact answer. Estimate when you can, choose that answer, move on, then come back and do your flagged problems. Let's look at example 3. The price of a new television has been reduced by $500. If the original price was $2,150, what was the percent decrease in the price? I'm going to switch over to my .cam, and I find it easier to write this stuff out over there. So let's take a look at this problem written out. See if you can pick out the numbers that you're going to need for this, and think about the formula that you will work best for you. In fact, I'm going to give you a moment before I switch over to .cam. What would you write on your scrap paper? What values would you choose? Which formula would you think of using? And don't solve it yet, because we're going to try to approximate, but I want, or estimate. I want you to at least be thinking about the numbers we would use. Okay, so let's take a look. Got a price reduced by $500. The original was $2,150. What's the percent decrease? Okay, so the price is well, 500 over, how do we want to do this? Let's say we've got the percent decrease, let's use our formula first, is equal to a discounted amount or reduced amount, reduced or discounted amount divided by the original amount times 100 to turn it into a percent. Okay, well, what if this was 2,000? I'd have 500 and 2,000. Do you see how this is 1/4 of the original amount? The percent decrease in the price is about 1/4 of the amount. So our answer is going to be approximately 0.25. Not exactly, but if I had, times 100, sorry. So approximately 25%. If I have a bunch of numbers that are close to 25% in my answer choices, well, I need to keep working. But if there's one that's close to 25% and another one that's greater than 50 and one that's less than 10 and one that's closer to 100%, well, then I know I can narrow it down this way. Just by doing a little bit of rounding The 500 was already pretty perfect, but 2,000, that's about 4 times more than the amount it was discounted. So about 25% of a discount. Let's go ahead and actually plug in the real numbers. Let's say we've completed our solving all the problems, and now we want to do a flagged problem and come back. So our percent decrease is going to be equal to 500 divided by 2150 times 100 to give us our percent. And that comes out to be, I've got 500 divided by 2,150 times 100, and I get 23%. What do you think? This looks good. Considering we were expecting an answer close to 25%. I like it. I'll put it in a box for somebody to check their answers easily if they're not listening to all the explanation. Let's try the next example, example number 4. I'm going to switch on over to my main screen, and let's see what we've got. A house purchased in 1998 for $170,000 was recently sold for $245,000. Yes, the market is doing really well right now. What was the percent increase in the cost of the house? I want you to think about which numbers are important and which one of these forms were we given? We're asked for percent increase. Did they tell us flat out the amount that it was increased? Or did they give us 2 values and we have to do the subtraction? So I bet this page is going to look a little bit different if you're in one of my classes in the future, because I can already tell I'm going to be changing this to, this would be equal also to reduced or reduction. And it also could be increased. Is that what we were given? That it went up a certain amount? No, we were told an old value of 170,000 and a new value of 245,000. They didn't do the subtraction for us. We're going to have to do it instead. So I'm going to switch over to my other camera, and you go ahead and pause your playback and see if you can do this one yourself. So when you wrote down the information, did you write down and assign the old and the new to make sure that you did not get those two confused when it came to dividing? Hope so. Hopefully you did your 245,000 minus 170,000, and you have to get that answer. And then hopefully you divide by the original amount. So this will be 75,000 divided by 170,000 times 100. And I got 44% increase in the price. Let's see, I think that seems reasonable. I mean, we went up, if it had been 100% increase, then it would have been 170 plus 170. In this case, it increased by $75,000. Well, half of 170 is what, $85,000. So it's going to be a little less than half of the original amount added on. So 44% seems reasonable to me. Sounds good. Let's take a look at the next example. Example number 5. The price of a wallet is discounted by $8.50. If it originally cost $23.99, what is the percent decrease in price? Okay, and we're thinking about an estimate here. So what if we rounded, definitely we'll want around $23 to probably $24, right? $23.99 to $24. And if you're fairly good with your multiplication table, then you know that 8 goes into 24 evenly. 8 times 3 is 24. So it looks to me like they've taken away 1/3 of the amount. If 8 times 3 would give us the $24 originally, then it's been discounted by 1/3, or approximately 33%. So I can type this in here. 8 is about 1/3 of $24. So we're going to expect about a 33% decrease. Now you could look for an answer choice, and if you get lucky, there'll be something around 33%. If not, then you'll need to solve the problem. So go ahead and pause your playback and see what the exact number is. But I have a feeling it's going to be close to 33%. While you're doing that, I'll just switch over the long way. Our discounted amount is 8.50, original 23.99%. Decrease, the formula could be a discount over original amount or reduced amount over original times 100. If you took the time to figure out that the new price was $8.50 less than the original price, and then you plugged it into new minus old divided by old, you'll still get the same answer. You've just done a whole lot of extra work beyond what you needed to do. Remember, the bottom line is it's the amount of change divided by the original amount. If they're already telling you how much it's changed, you don't have to do all those extra calculations. In this case, we're going to take 8.50 and divide it by 23.99 and multiply by 100. And my calculator says that comes out to be 35%. And that's pretty doggone close to 33% that we estimated. So I'm liking that 35% value. Let's take a look at the next problem. I'm going to stop the recording here because what we've done is gone over the basics about what a percent is and going between fractions, decimals, and percents, and we've done the percent increase and decrease in amounts, and that seems like a good end to this first video. The next one is where we're going to calculate the percent, calculate the part of the total, and calculate the total amount. So if you'd like, go ahead and check out that next video to continue solving these common percent problems that you'll find on the tees. As always, feel free to email me if you have any questions at all about what we've just done.